Okay, hello everyone. So we'll get started basically now. Today we're gonna be reviewing a bit of some old stuff meaning like yesterday's stuff, and then talking more in depth about React. So things we learned like state, props, lifecycle, things like that. So make sure to pay attention because a lot of this will be useful for the workshop in an hour. Next, okay. So a few announcements. Milestone 0 was due yesterday, so we have until 5 p.m. ET today. We're basically going to be a little bit lenient this time since it's the first milestone. But basically, if you didn't submit 10 valid ideas, meaning like not real ideas, like you put NA or like copy paste some other idea in your list, then that's not a valid idea. So you have until 5 p.m. ET today to resubmit, else you can't compete or receive credit. And yeah, if you have extenuating circumstances, please contact staff. So remember to join the web lab queue for individual help and join breakout rooms 22 to 28 to receive individual help. And questions doc is always at weblab.2/questions. Please read Piazza pin posts. Like a lot of people ask questions that are already answered in the pin post, so just please read them. And look out for milestone 1 signups that are going to be coming out after class. So yeah, let's get started. First, let's review what a component tree is and why we use it. So a component tree is basically just an abstraction that represents the hierarchy of components within, in our case, a web application. So this is useful when the code is getting too long or hard to read. And you can think of it as like you're building a house and you wouldn't want to build the entire house all at once. Like you would want to have specific plans for different rooms, bathroom, master bedroom, kitchen, etc. And components also contain parts that usually encapsulate their own information. So you would think like if you're trying to abstract or describe a shopping mall, you wouldn't just like, let's say you're trying to like, I don't know, code something that represents a shopping mall. You wouldn't want to create like one entire file that has like thousands of lines of code, right? Like you want to probably split it up into something like, oh, each store has its own set of staff, merchandise. So it makes sense to break it down into different stores and things like that. And last but not least, with this structure of a component tree, we can pass information downwards through props, which we will also review later. So you can basically think of it as refactoring your code to make your life a bit easier as the architect of a web application. So this is a screenshot from Quora, as I'm sure most, if not all of you know. And let's try a small exercise like we did yesterday to try to split it up into underlying components. So feel free to drop in the chat what you think some of the possible breakdowns should be. Let's have some more suggestions. Thanks, Shannon, but no. Yeah, so these are all good ideas. Basically, the biggest one that we see here is the one in the middle, which is the feed. And we also have the nav bar, which people mentioned, left sidebar, right sidebar. And we can also split each box into even smaller components. So I highlighted some here, like we have the compose box on the top, we have the post, the different sections of the right sidebar. And actually we can even like split these small things into components themselves. So like the icon with the, yeah, like these can be their own cards and things like that. So this is the component tree that we went over yesterday. If you have questions, please drop them in the doc. Otherwise, we're going to move on to reviewing states and props. So yesterday we went over states and props pretty quickly, but these are actually very important concepts to know when we're building our website in React. So we're going to review some stuff and then go a little bit more into detail as to what you can do with state and props. And please make sure to ask questions if you don't understand, because if you don't know how to use states and props, then it'll be very difficult to build a website in React. So before we go on, a reminder from yesterday, you cannot edit a component state from another component directly. So occasionally in our code, we might have some instances, like reasonable instances, where we might want to like try to accomplish something like this. But like here I'm saying like you can't do that. So like what should we do in that case? Well, there's a workaround. Basically, we want to pass the setState function to the child and then call it from the child component using this.props. So if you don't understand this right away, it's okay because this is a workaround. Like you shouldn't need to use this if you're designing your code well, or if you're like, yeah, using good coding practices most of the time, you shouldn't need to use this, but just as like extra information. So let's say if you have like a parent component and you have this function called change cat happiness, and in change cat happiness, you set the state to increment cat happiness by 1. Okay, yeah. So you probably need to use this sometimes, but like most of the time you should not be using stuff like this. But yeah, just pay attention. So and then let's say we want to change the cat happiness from a child component. So then we would pass a prop in, which is basically the change cat happiness function, as a prop called update function. So then that means that in child component, you would be able to call this change cat happiness by indirectly calling it. So use this.props.update function, and then you would be able to increment the state of cat happiness, increment the state of parent component, increment cat happiness in parent component. So yeah, so keyword is that this is a workaround, and the stuff is a little bit convoluted, but yeah, hopefully this is helpful. So now the difference between states and props, like we mentioned before, states stay and props pass. But do we remember which way props pass? So drop in the chat which way you think props pass. And all of you should know this. The chat should be popping off right now. Yeah, so props pass down. This is very, very important. If you try to pass props upward, I will be very sad. So please make props pass downwards. So let's do some props practice now. This is a Twitter tree. On the top, we have the Twitter app, and then it points down to different pages like profile, feed, and the nav bar is a module like we saw yesterday in the workshop. And then feed also can be split up into tweet. Tweet can be split up into comment and like. So these things on the right here, let's say like, let's just black box it for now. So let's say the Twitter app gets these attributes from like the database. Somehow it just like gets them in there. And then let's try to see like which of these things in the list could be props to be passed down from the app into its child components. So feel free to drop in the chat. Which of these should be passed down as props? Yeah, so username is a big one. Like we obviously want the username to show up in the profile. We also probably want it to show up in the feed. The answer is actually all of these would be useful in passing down as props. So especially on profile and feed, we would want to use a username. We would want a list of posts so that we know which things to display in the feed. And we also want to know followed users and followed by users because they're displayed on profile. And you also want to know the followed users to know like which posts you should display on the feed, right? Like you don't want to display posts that like you have no relevance to, like you don't want to see them. And so, yeah. And then these properties like username things can be held as state in profile and feed. So now second exercise, instead of looking at the big umbrella Twitter app, let's look at a tweet component itself. So a tweet component, let's say it gets a poster, post content, and post ID from the database. And which of these should be props that are then passed down to one of tweet's child components? Feel free to drop into the chat. Yeah, so post ID is the thing that we want to pass down as a prop. Basically, poster and the post content, it's important for the tweet object itself. So we probably want to hold it there as like some form of like state or something, but we actually like it's not relevant to the comment and like. Like if you're just rendering a comment, you don't care like who posted the post like that it's attached to. But we do want the post ID because we want to know which tweet that the comment or like is associated with. So the post ID is an important thing that we want to post. We thought the poster was relevant to the comment. So like, sorry, can you clarify? Oh, it shows up who you reply to. Okay. Okay, yeah, sorry. I like this is just like a basic abstraction, like just caring about like the comment itself. So that makes sense. Yeah. In Twitter specifically, it shows who you're replying to. But to say in some social media apps, like if it doesn't say like who you're responding to, like if it's just like a comment object with like the comment poster's name and like the comment content, then you wouldn't need the poster. So yeah, in that case, you probably want to pass the poster down to comment as well. So now let's go a little bit more in depth on state and how to control it. So how to set state. We went over this briefly. Nico went over this briefly yesterday in the workshop, but we'll just review it again. So basically in the constructor, we want to initialize state with the attributes that we want. So this has like 2 lists and 1 Boolean value. And yeah, this is similar to like a Python dictionary initialization syntax. And if we want to retrieve state, we just do this.state, which is basically a JavaScript object. And we can do like this.state.pets, this.state.persons, like whatever attributes you put, you just do this.state and you can retrieve it. So now if we want to modify state, we might expect to do this, like set it equal to the property because like it makes sense, like, right? But this is actually incorrect. As mentioned before, we want to use a special function called setState to modify the state. So don't use the thing on the bottom. Your code will not work and you'll be set. So if you want to set like something like exists equal true, then you can just do this dot set state parentheses curly bracket exists colon true. And notice how everything is enclosed within the parentheses of the set state function. And if you want to modify the original state, we can do something like, so we want to use the original state and then add to it. So let's say this is a list, we want to add dog to the list, then we just do this.state.pets.concat, and then we put the new list in the function arguments. So this is basically the same idea as the thing in the previous slide, except it's safer. So this is a recommended practice from React. Basically, if you want to, we're going to sort of like black box it, but basically if you want to change state really, really fast, let's say you're making it like a to-do list website, and like you might expect users to like click like 10 items off their list within like a second. And sometimes if you do that using like the previous syntax, like using this, it might get messed up, like your state might not update correctly. So this is like the safer option using the keyword prev state, which represents previous state. So you just use prev state and arrow function. And then this is the spread operator, like Justin covered on Monday, Tuesday, something like that. And then this is the same idea. So yeah, this is the safer option. You can use the previous one, but this option is more recommended. So yeah, previous state keyword. So now that we know how to set state and retrieve state, let's look at this example. So what do you think this function will print to the console if we call it? React, use the zoom reactions on the bottom of your screen. React a yes for A and a no for B. Let's see what you guys think. Okay, so the answer is actually, we don't know. So there's no guarantee as to whether our console will print A or B, and in practice, it would most likely print A because this .setState is an asynchronous function. So if you remember async functions from yesterday, once setState is called, we don't expect it to execute or finish right away. So React actually does this thing where it groups certain number of set state calls together and then processes them all together in a batch to boost performance. So this is good for like website performance, right? It makes websites fast. So this is why React is so powerful in web development, but it can create some unexpected behaviors if we're trying to rely on the output of our states to be certain values. So what if we want to do something immediately after a state is changed? Like if we just put a line of code right after this .set state, it won't do the right thing most of the time, unless your computer is really slow. So we would use a callback function in this case. So basically, in this example, a callback is the part that's boxed. And if we use a callback function, notice how everything's within the parentheses of set state, then this console.log would happen after the state is set. So if we put console.log down here outside of set state, then it wouldn't do the right thing. But if we put it inside as a callback, then it would do what we want. So it would happen after the state is changed to concatenate algorithm to our list. So now I'll pass it on to Kai, who will review lifecycle methods.
Cool. Yeah, let's jump into lifecycle methods now. So you probably remember these briefly from Nico's lecture yesterday. He talked about, for example, render was the main one that we talked about, and we talked about the constructor. So you might remember what the diagram looked like from yesterday. It was probably something like this, right? Constructor, and then render, and then every time there's a change in state or prop, render gets called again. Every time there's a change, we re-render. Okay, I'm just going to redraw this diagram real quickly to make it a little bit more clear. You'll see this in a second. It's the same thing, just slightly different shape. So one thing to note here is that you might be tempted to write code that modifies the state of your component within the render method. And from this diagram, you can probably see why that might be a bad idea, right? You guys want to drop in the chat why it might be a bad idea to update your state or call set state in your render method? Yeah, people are getting it. You can imagine this could very quickly turn into an infinite loop. This little cycle here will just go back and back very quickly. Fortunately, React will actually catch this for you and warn you about it instead of like killing your computer or something. But you don't want to do that. It will cause errors in your application. So takeaway, do not call set state within render. Cool. So let's add a little bit more detail to this diagram now. So it re-renders every time you call this .set state or its props change. And we're going to call this initial render on the top here. We're going to call that the mount. In React, it's the terminology we'll use. Mount is the initial render. It's kind of called that because it's when React actually takes the component and initially puts it on the page. So if you remember from the snake game, when we did like document.append child or something like that, React actually does that same thing internally and it calls that the mount. So that's what the initial render is. Okay. So actually after the mount, there's another thing that we haven't told you about yet called component did mount. And the way you should think about that is just after the initial render or the mount, then any code that you put inside component did mount will get run. So I'll go over this more detail in a second, but you might want to fetch data in component did mount. You might want to do other actions, that kind of thing, after the component initially gets put on the page. Cool. And then the last thing I'm going to add here is update. So any later render call is called an update. So the initial one is the mount, any later one is the update. And there's actually one more thing here called component did update, and it mirrors component did mount. Just any code you put in component did update will get called after these secondary renders. Cool. Any questions about that so far? Feel free to drop small questions in the chat if you would like to. All right, let's jump into a little bit more detail on what we might use. Oh yeah, render is just going to be the method that we talked about yesterday that will return the HTML that React puts on the page. Okay, a little bit more detail. Component mount is only going to run once every time the component gets put on the page. So you can think of this as after component first renders. And the most common use cases are to load some data, either usually into state. So it might call an API. So if you remember Noah's lecture on APIs and async yesterday, you might make an API call in component mount. You might perform some like heavy computation, something else like that. And then you might want to put that data into the state in component mount. Component update is very similar. It runs after every render except the initial one though. So you can think of this after every time that the component re-renders. It's not as commonly used, but it can still be useful sometimes. So an example use case might be if you're validating a form, maybe you want a little green check mark to show up after like you verified that an email is not used or something like that. After the component updates, you might want to do some logic to check if that email was valid and then set some state to put the green check mark on the page. Or autosave functionality. So every time someone types something, it will automatically send something to the server. Cool. There are other lifecycle methods. I've linked a diagram here. You don't need to know this because they're not going to be used for the most part in your websites, but there are a couple other lifecycle methods, and you can just think of them as adding a few more things to this diagram here. But don't worry about those other methods for now. Cool. Any questions about lifecycle methods before we jump into get and post? Feel free to drop ones that you think would be useful in the chat. I noticed someone asked in the questions doc about waiting. The way you should think about that is just the React library is the one keeping track of all of these updates and stuff. So this waiting box just means that nobody has done any action on the web page for a little while, and the React library isn't really doing anything at the moment. It's just waiting for user input, and then it will call one of these methods once there is some input that causes a state or props change. So most of the time React isn't doing anything. That's this waiting, and then sometimes it will be doing things. Cool. Let's jump into get and post. So Noah talked about APIs yesterday in sort of a high level capacity. So you're sending information from the client to the server, and then some information comes back. And he talked about different methods like get and post. In WebLab, we actually have provided a nice little file called utilities.js that abstracts away the actual writing pure JavaScript code. And you can just call the methods get and post, and they will look like this. It's a nice simple syntax. We've handled a few error things for you. We recommend using the things in utilities.js. But when you do use those, it will look just like this. That's all you need to call them. So when you call get, it will make a get request to the API endpoint that you specify as the first argument. So in this case, we're querying the server at /API/foo. And then it will send any data that you give as the second argument. So in this case, it's sending bar0 as the data back to the server. And then as Noah talked about yesterday, since this is an asynchronous promise-based function, you can then use .then here and give it a callback function. Anything you put in the callback will get called once the network request to the server gets completed. So once the data comes back from the server, it will be in res or result. You can call this argument whatever, but then all this does is when the data comes back, it will console.log it. So here's an example usage of how you might use that in an actual web app. This is an example from a web app I wrote for my dorm that just handles packages for the front desk of the dorm. In this case, get is getting called to /API/packages, And then whatever data comes back, we're going to actually combine that with what Claire talked about earlier, this .set state. And we're doing this in component did mount because we want this data to come in once the user loads the package list component on their page. So once they click on whatever button or navigate to whatever page that has this component, the package list component on it, component did mount will get called after the component gets put on the page, like we talked about earlier. And then we're going to make the GET request. And then when the GET request finishes, when we get the data back, we're going to call this.setState and just put that information in state. So that information is now saved into state, and we can use it as a regular JavaScript variable. And remember that once setState gets called, we'll actually get the render method called again. So the component will re-render, and any new information, for example, all the packages, will be taken into account in that new time that render gets called. Okay, so then the other thing you might want to do is send data back to the server. And as Noah talked about, you might commonly use the post method to use this. This is an example usage from the same web app of using a post request. In this case, when you click a button, so this is just some React component called button, doesn't really matter what's in that component, but React actually exposes something called onClick, and all that does is whatever function you hand it here, it will call that function when a user clicks on that component. So this is handle toggle admin is just some function that I wrote, and React will call that function. It will make sure that function is called when a user clicks on this button. So here's what handle toggle admin might look like. It might make a post request to the server, in this case to /API/user/admin. It might send some data. So in this case, it's just toggling the current state of whether that user is an admin or not. And then when it's finished with that, it's going to have this callback to just set state to the same thing. So all this is doing is updating the data on the server. And then when the server completes that request in the .then, it updates the UI or the state to match. And because it's this .set state, React is going to call the render afterward. It's going to re-render or update the component with this new information, and then the UI will begin to show that. Cool. So this is just an example usage, pretty common usage of use case of how you might want to call post or make a post request to the server and send something. Okay. If there are any high-level questions about get and post, feel free to drop them in the chat. Otherwise, we'll move on to some JSX and render stuff. Cool. The first argument to get and post, we'll call that an endpoint, but that's just something that you're going to specify on the server. I think tomorrow we get into writing server code, and you'll see what that means. You'll see where you specify what this is when we start writing server code. But basically, this is just a unique string that you will specify on the server, and then when the server gets this, it will respond accordingly. Okay, yeah, let's just move on. So this is just a quick review of JSX. If you remember JSX from Nico's lecture, it's just a simple way to write HTML onto the page, but from inside JavaScript. So it's mostly used in React, and the syntax looks something like this. You can just assign a variable name or return or whatever, just like normal JavaScript stuff, but with HTML here. So you can see the H1 tags that look like HTML, but we're writing inside JavaScript. You don't really need to know this for the class, but in the background, React will, when it compiles this code, it actually just translates these into regular JavaScript. So why might this be useful? Yesterday, when Nico showed you guys that you mostly did static content. So in the render methods, you might have just returned some static HTML that you had written ahead of time. But very importantly, since we're using JSX, anything is a variable now, or it can be assigned to a variable. It can be modified just like a variable in JavaScript, just like a full programming language that you have accessible to change your UI and modify your UI. So in this case, this is a very simple example of what you might want to use with JSX, is just assign things to variables. And that makes it a lot easier to separate out concerns. You can write your render method in whatever order that you want. And because these are variables, you can now modify them. So an example of, let me actually just review how this works. It's a little bit confusing, but we're writing JavaScript code. So this is a JavaScript file. But then as soon as you add an HTML tag like this, we go into HTML mode. That's the way you can think about it. And so this is HTML. And then as soon as you add the curly braces again, you go back into JavaScript mode. I know this is confusing. So JavaScript, HTML, and then back to JavaScript again. But anything inside these curly braces is completely valid JavaScript. And so a variable name like header or content works fine, or whatever, a mathematical expression, any expression, a function call, you can put anything JavaScript there. Okay, so let's run through a quick use case of where this might become useful using JSX to actually dynamically render content. So it's a very simple example. Maybe you want to display a loading indicator. So there's some state in your component that indicates whether or not the page is still loading data, whether it's still waiting on data. And we want to show a loading message while it's still loading. Otherwise, you just want to show some piece of content. So here would be the simple way to do that. Conditional rendering is what we're going to call this. Just based on some conditional, we want to render different things. Since JavaScript code, we can just say if this.state.loading, and we can return this thing with the loading message underneath. Otherwise, we can return this thing with the actual content underneath. But you might notice that we had to duplicate the header code here, and we had to duplicate the div here. You can see how that could get pretty annoying pretty fast if you had to have a different if branch for every single different possible thing that you might want to render in your render method for your component. So there's a much simpler way to do this with JSX. Because we can use regular JavaScript variables, we can just initialize content to null. And then depending on whether or not the state is loading, we can modify the content of the variable content. Maybe I should not have named this variable content. Okay, basically content is going to contain different HTML depending on whether or not this.state.loading is true with this if statement. And then because we use content down here, it will render the exact same thing as the previous example. So this and this will render the exact same thing, but the second one is much more modular, and we could expand this a lot more easily to more if statements, more different variables, lots of different content. And then Nico showed you this yesterday, but an even quicker and simpler way to do it is using something called the ternary operator, which is a pretty common pattern in React. So in this case, because anything inside these curly braces here is completely valid JavaScript, we can just put a ternary operator and say this.state.loading. And remember, the syntax is the result, if it's true, is the first thing, and if it's false, the second thing. So if this.state.loading is true, then we'll display the loading message. Otherwise, we'll display the content itself. So these three examples here all render the exact same thing, but you can see we've used different aspects of JSX and like the nice parts that come with JSX, putting like embedding JavaScript inside of our HTML, or in this case, assigning our HTML to JavaScript variables. We've used the different advantages of JSX to dynamically render content on the page, depending on the state. And you could also do the same thing depending on props. Cool. Okay, let's move on to one last piece of content on React. So the last thing, one more thing that you might commonly run into when creating a React application is something I'm going to call loop rendering. But it's just a really common pattern to need to render an array of data, not just a single item. So in any feed component or a list of comments or a list of users, you're going to have an array of things in JavaScript, and you need some sort of simple way to take that array of JavaScript objects, normal variables, and then map that to HTML. And I am using the word map here intentionally. You might remember the function called map that we went over in the introduction to JavaScript. So the function called map, all it does is creates a new array by applying some function, a callback function, to every element of the starting array. So in this case, we've got this is, I think, the same example Justin used the other day, but we've got some array 1, 2, 3, 4, 5, and we call it .map, multiplying each element times 3, and you end up with 3, 6, 9, 12, 15. Fairly straightforward. It just creates a new array from an old one by applying a function to each element in that array. .map turns out to be extremely useful in React. So in React, you might have some list of elements. In this case, it's just an array of JavaScript objects that contain an ID and a name. And let's say we want to render each of those, but not as just, a JavaScript object. We don't want these colons and the curly braces and stuff like that. React, okay, this isn't strictly true. React can render this thing on the left. It just is going to look gross. It's going to look like a JavaScript object, which is not quite what we want. But let's say we want to actually do something reasonable with this data. So for example, we want to put the name in a div and then render that. So if we use .map, it will put each of these items through the callback function. And then we'll end up on the other side with our 4 divs with the 4 names inside of them. And React can render this in a nice way since it's just JSX. So what does that look like in actual code? Let's see an example. So for HTML, we might want to have some array of data like this with an ID and some text. And we want to render this text inside of a div for each item in the data array. So here's our .map, and we're feeding it a callback function that takes an item, and then it returns a div with item.text inside of it. So there's one other important thing here that you probably haven't seen yet is the key thing here. React actually requires you to give a key every time you render an array of things. It doesn't matter too much why you need this key. I guess the TLDR is that React needs to keep track of which item is which internally. And so you need to feed it some unique identifier to tell it which item is which. So in this case, we're just using the ID thing here. And you can see in the comment here what this will actually end up rendering in React. It's going to be an array of elements, which React can render just fine, an array of divs where there's a key and there's some text. And we can do the exact same thing with components. So in this last example, we just did it in a div, but we can also do this with components. So let's say item component is some other component that we've written in a different file, other React component, that takes a prop called content. And maybe it might render anything with that prop called content. We don't really know. But with using the .map pattern, we can also just render an item component for each array in data, or for each item in the data array. And we do still need a key, and we're handing it this content prop. So now it's going to render 2 item components with the different props. A slightly shorter way of doing this, you'll notice that I have the curly braces here in this callback and the return here. But you might have noticed in some of the callback functions we've written, we don't always have that. You can actually do this, which is equivalent. If you don't include the curly braces, you can skip the return statement. If you do include the curly braces like this, you do need the return statement. But if it's a short 1-line thing like this that you're using in .map, you can usually skip the curly braces in the return statement. And this will render the exact same thing. Awesome. So hopefully you guys now have the building blocks to build a fully functioning React app that actually dynamically shows things and does interesting things. And that is it for this lecture.